For my video, I will be showing how a carboxylic acid can be converted to an amide by drawing the mechanism. So, when converting a carboxylic acid to an amide, an activator such as DCC or dicyclohexyl carbodiamide is used because it prevents an acid-base reaction from occurring where the alcohol on the carboxylic acid would become deprotonated. While a base could be used along with heat to deprotonate the carboxylic acid, an amide would only form sometimes. Therefore, using DCC is more efficient. So, the oxygen of the alcohol has electrons and the carbon on DCC wants electrons. When a carboxylic acid behaves as a nucleophile, the alcohol is usually what adds. The nitrogens here are partially negative. So, a pair of electrons from the oxygen come out and form a bond to carbon, pushing a pair of pi bond electrons onto one of the nitrogens. So, this forms this molecule. Now a proton transfer occurs where a pair of electrons from the now negatively charged nitrogen comes out and grabs the hydrogen on the oxygen, pushing the pair of electrons onto oxygen. This eliminates its negative charge, yielding this neutral molecule. Now the amine can come in and attack at the carbonyl carbon, pushing the pi electrons onto oxygen. Remember that other amines, such as a few drawn on my introduction slide, can also be used in this reaction. Now we have a good leaving group, so the electrons from oxygen can form a double bond, pushing off this oxygen to form a new carbonyl, and then pushing the pi electrons onto nitrogen to avoid having 5 bonds to carbon. Another proton transfer occurs and the electrons from the negatively charged nitrogen steals the hydrogen from the nitrogen, pushing the electron pair onto nitrogen, forming the amide and dicyclohexylurea, which is ultimately the driving force of this reaction because it is so stable.